In this video, we will be talking about subnetting. So subnetting is basically nothing but dividing a network into smaller networks. Suppose this is your network, and if you divide this network into some smaller network, then this is called subnetting. Now those smaller networks could be anything in number. Let's suppose I'm dividing this network into 4 networks. Then these are the 4 subnets. Right? This process is called subnetting. And why we do subnetting? Because we need easier maintenance, and also sometimes we need security. Like we want to secure each network individually. That's why we need subnetting. For example, suppose in a university there are different departments. One is electrical engineering, one is computer science, one is art department, and I am dividing each of this department into one subnet. Instead of having all of this is as one network, I'm saying that I want to have this as one network, this as one network, this as one network. So these are 3 subnets that I have divided here. Now for example, that I have this as one network and I want to divide this network into 4 networks. Then let's see how to do it. This is one of the network and I want to divide this network into 4 networks. So if you just notice here, these 24 bits are fixed. You can change these 8 bits, which means number of hosts possible here are 2 power 8, which is 256, right? These many hosts are possible here, and I want to divide this into 4 networks. Now if you divide any network into 4 networks, then you will be needing 2 bits for the subnet ID. What I mean by that? See here, initially you have these 24 bits, right? These are 24 bits, these 24 bits as your network ID, and these 8 bits are there for your host ID. This is before subnetting, but you need to divide this network into 4 networks. So that's why you will be taking 2 bits from the host ID, which means now after division this will be your network ID, this will be your subnet number basically, and then remaining 6 bits will be your host ID. These are the 6 bits. This will be your host ID. These are 2 bits and these are 24 bits. That's how you will be dividing a network into 4 networks. So what I mean by that? That for the first subnet you will be having 0 0 0 0 will represent your first subnet 1, 0 1 will represent your subnet 2, 1 0 will represent subnet 3, and 1 1 will represent subnet 4, right? This is how these numbers will represent these subnets. Let me go to the next page and let me show you how it is happening. 192.168.9.0/24. This is your network, and now let me write this in binary. I'm not going to write 192 and 168.9. I'm not writing this in binary because these are anyway fixed. Now I'm writing only 0 in binary. So this is your binary representation of 0. Now I'm saying that these are the host bits. These are the host ID. Now from this host ID I am borrowing 2 bits for the subnet, which means now your 0 1, this thing, or 0 0, this thing will represent one subnet. Now you can change this host ID to anything, which means that there are 6 bits in the host ID and there will be 2 power 6 IP addresses are possible, and if I talk about hosts, then there will be 2 power 6 minus 2 hosts are possible. So this is your first subnet 1. In this subnet 1, you have hosts ranging from 192.168.9.0 0 0, this is fixed, and then all zeros to 192.168.9.00 to all ones, right? Which means 192.168.9.0 to 192.168.9 dot, this will be 63, right? 9.63. If you put all ones, it will be 63. So these are the range of IP address in subnet 1. This is range of IP address in subnet 1. I hope you got the idea. Now this subnet 1 will be having its own network ID or subnet ID, and will also be having its own directed broadcast address DB, which means the first address will be its network ID, which is 192.168.9.0, and the last address will be its directed broadcast address, which is 192.168.9.63. This is all about subnet 1. Now similarly, you will be having subnet 2. So for subnet 2, you will be having, instead of 01, 00, you will be having 01, which means 192 for subnet 2, 192.168.9.01 you will be having, this is fixed, and then you will be having these 6 bits for the host ID, which means you will be ranging from 192.168.9.01 and then all zeros, 6 zeros, to 192.168.9.01 and then all ones, right? Which means this range will be 192.168.9.64 to 192.168.9.127. This is the range of IP address in subnet 2. And what will be the network ID? Network ID will be the first address, which will 192.168.9.64, or if you want to call it, then you can call it subnet ID. And what will be the directed broadcast address for this subnet? It will be 192.168.9.127. And what are the number of hosts? Number of hosts here are, since there are 6 bits, so there will be 2 power 6 minus 2. Why minus 2? Because of these two addresses. So it will be 62. I hope you got the idea. Similarly, there will be subnet 3 and subnet 4. So let me write all subnets in one table. Let's say this is subnet number 1, 2, 3, 4. This will be, let's say this is subnet ID. Let's say this is directed broadcast address. Let's say this is range hosts range. Now for the subnet 1, the subnet ID was 192.168.9.0 and directed broadcast address was 192.168.9.63. Now here it was 192.168.9.64 and directed broadcast address was 192.168.9.127. Now it is 192.168.9.128. Why? Because for the subnet 3 you will be having, this is basically 00, this is 01, this is 10, this is 11. So you will be having 10, which means 192.168.9.10 is fixed and then all zeros. So if you put all zeros, it will be 128. If you put all ones, then it will be 192.168.9. If you put all ones, then it will be, I think, 191. Right? 128 plus 63, it is 191. Yeah, it will be 191. Now here in the subnet 4 you will be having 11, which means 192.168.9.11, and now you can range this, which means 192.168.9.192 to 192.168.9. If you put all ones, it will be 255. These are the subnet IDs. This is the directed broadcast address for the each subnet. Now for the host range, you can just say it will range from 192.168.9.1 till 192.168.9.62, because after the network ID or subnet ID there will be one host, and before the direct broadcast address there will be one host. So the host range will be this, and number of hosts are 62 in every of this case. So number of hosts, if I want to write, let's suppose there is another column which is saying number of hosts, then this is 62, 62, 62, 62. These are number of hosts. And you can write down the range, which means here it will be dot 65 till 126, because after 64 this is 65, before 127 this is 126. So that's how you can write down the host range also. I hope you got the idea about the subnets. Now let's say I want to divide this network such that each network has 10 hosts. So here they are not saying that divide this network into 4 networks. They are saying that it is up to you, like how you divide this, but you need to make sure that each network has only 10 hosts. Now suppose that there are some host IDs for each network, like some number of host ID, maybe 3, maybe 4, maybe 5. But whatever it is, like if the host ID is, let's suppose, 5, then the number of hosts will be 2 power 5 minus 2, or approximately 2 power 5, which is 32. So basically you cannot have 10 hosts. You will be having, like, if 5 is the host ID, then you will be having 32 hosts. If 4 is the host ID, then you will be having 16 hosts. If 3 is host ID, then you will be having 8 hosts, right? Approximately, I mean, minus 2 will be there. So in this case 30, in this case 12, in this case 14, in this case 6 hosts. So you cannot have 10 hosts. So in this case I will go for 4 host ID. Why? Because I cannot give less host, which means I cannot give just 6 hosts because the demand is for 10 hosts, and I cannot give the more hosts, which means I cannot give 30 hosts. So that's why 4 host ID is the accurate one, which will give me the 14 hosts which are okay, because I cannot do better than 14. So that's why I will use the 4 as host ID, 4 bits as host ID. So here, see, this network ID is fixed, so 24 bits are network ID, and subnet number I need to find out, and I know that 4 bits are for the host ID. Now in this case, what will be the subnet number? So it will be 24 plus 4, which is 28, and then plus 4, which is 32. So that's why 4 will be here. This will determine my subnet number. I hope you got the idea how I am writing it. It is given. It is I calculated because of the 10 hosts. Since there are 10 hosts, that's why I calculated it as 4 bits. And then I needed to find out what is the subnet number, like bits required to identify the subnet number, which are the 4 bits. Now that is easy. What you need to do, you can just say for the first subnet it will be like all zeros, and then for the subnet 1 it will be all zeros, and then 0001, then 0010, then 0011, like that. You can write all the subnets. So how many subnets will be there? Number of subnets, it will be 2 power 4, right? And each subnet will be having how many hosts? Each subnet will have how many hosts? 2 power 4 minus 2, which is 16 minus 2, which is 14 hosts. They require 10 hosts, but I am giving 14 hosts. I mean, 4 will be wasted, 4 IP addresses will be wasted, but that is okay because I cannot do better than that. So I hope you got the idea. Now you must be wondering about one question, which is what is the subnet ID and directed broadcast address of these networks. So you can find it out how. You can just put all the zeros. So for the subnet 1, let me calculate. For, let's suppose, subnet 3. In this case, this is 0010, right? There will be network ID before that, and these are changeable bits, like these are the host ID and you can change them. So basically, what will be the network ID, network or subnet ID for the subnet 3, network ID for subnet 3? It will be 192.168.9.168.9, because this is the network ID, and then dot, I'm writing it in binary 0010, and then all zeros, 4 zeros. This is the network ID, which is 2 power 0, 2 power 1, 2 power 2, 3, 4, 5. So which is 32, which is 192.168.9.32. This is the network ID for subnet 3. What about directed broadcast address? It will be directed broadcast address for subnet 3. It will be 192.168.9.0010. This is fixed. Now you can take 1111 here, which means this is 15 and this is 32. So 32 plus 15, it will be 47. So it is 192.168.9.47. This will be the directed broadcast address for the subnet 3. Now, what will be directed broadcast address for large subnet? If I ask you what will be the directed broadcast address for large subnet, then you will say it is 192.168.9. If it is large subnet, then it will be having all ones here. Then you are asking the directed broadcast address, that means all ones here also, right? And the host ID. So it will be 192.168.9.255. Okay, let me ask you one more question, some random question. What will be the network ID for first subnet? First subnet. Since you are asking for the first subnet, that's why it will be 4 zeros, right? This is 1, 2, 3, 4 zeros, and then you are asking for the network ID, which means 4 zeros here also. Now it will be 192.168.9.0, right? Now this is directed broadcast address for last subnet. This is network ID for the first subnet. So these are the these are the information related to subnets. But this subnetting is not visible to the outside world, which means if you are, if let's suppose this is the network, if you are outside, if let's suppose this is the router which is outside and it wants to send the packet to this network, then this subnetting, like inside, let's suppose you have divided this into 4 networks or something, or 10 networks or 16 networks, something like that, then this subnetting is not visible to this router. This is just an internal division. So how this router will get to know that if this is the network ID of the first subnet or this is the network ID of the whole network? Because from this router perspective, this network is 192.168.9.0/24, right? From this router perspective, this network is the whole network. But you have divided this network into smaller subnetworks, which is like 16 subnetworks, and in that case, let's suppose there are 16 subnetworks, and in that case the last subnet, let's suppose this is the last subnet, the last subnet is having the directed broadcast address, which is 192.168.9.255, and let's suppose this is the first subnet. This is having the network ID, which is 192.168.9.0, right? See here, the network ID of the first subnet and the directed broadcast address for the last subnet. This is what I have written here. But these are like before subnetting, these were the network ID and directed broadcast address for the whole subnet also. See, this is for subnet 1 after subnetting. This is for last subnet or 16th subnet. right? Last subnet directed broadcast address is this, first subnet network ID is this. Now this is after division. Before division, before division, I mean before subnetting, it was network ID for the whole subnet, which was 192.168.9.0, and directed broadcast address for the whole subnet will be 192.168.9.255. Now this is before division. Now for this router, the division is not visible, which means this router still thinks that network ID for the whole subnet is this. This is not related to any subnet. For the whole network ID is this. This is not related to any subnet. For this router, there is no subnetting and all. So this is the network ID for the whole subnet, which means if this router has to forward something to whole network, then it will still treat this network as one network and with the network ID this, which means it will not distinguish between the subnetworks. Similarly, if some packet it wants to broadcast some packet, which means some packet is coming up with the destination IP address like this, then this for this router the directed broadcast address, this is the directed broadcast address for the whole network, which means this packet will get delivered to every of the host in this network, not just this subnet. This is important to understand. I hope you got the idea. If this router has to forward some packet with the destination IP address like this, then this router will forward this packet to the every of the host, not just the host in the last subnet. Even though this is a directed broadcast address for the last subnet, but this is not visible outside the network, right? So if some packet is coming from here, then this packet will get delivered to every of the host in this network. Now, suppose some packet is coming from one of the network with the destination IP address. Suppose some packet is coming from this network with the destination IP address of this from inside. From inside, let's suppose like these are the routers for every subnet. Let's suppose this is subnet 1, this is subnet 2, and this is subnet 3. Let's suppose there are three subnets and these are the routers or gateway for these three subnets. So this is one subnet, this is another subnet, this is another subnet. And now let's suppose this is the last subnet, which is having directed broadcast addresses 192.168.9.255. Now if some packet is coming from this network or from one of the hosts of this network or this subnetwork with this destination IP address, then this will get delivered to only this last subnet, because internally the subnetting is visible. So if some packet is coming from this with the destination IP address of 192.168.9.255, then this packet will get delivered to only this subnet, the last subnet, because this is the directed broadcast address of the last subnet. But if some packet is coming from outside, then this will get delivered to the every of the host in the subnet, right? I hope you got the idea. Similarly, the network ID, this is visible. Like if this network ID is to be treated internally, then this will be treated for the subnet 1 only. But if this network ID is to be treated outside of this network, then this will be treated as a whole network, not just for this subnet. Okay. So for network ID of the first subnet and directed broadcast address for the last subnet are overlapping with the network ID of the whole network and the directed broadcast address of the whole network. But this is not a problem, because from the outside world the subnetting is not visible, and from the inside world everything is visible. Every subnetting is visible, which means this network ID will be considered as network ID of the first subnet only. Similarly, this directed broadcast address will be considered as the directed broadcast address of the last subnet only, right? Now let's solve this question. An organization is granted a block of address with the beginning address of this one. The organization needs to have three sub-block of address to use in its three subnets. One sub-block of 10 addresses, one sub-block of 60 addresses, and one sub-block of 120 addresses. Design the sub-blocks. So what they are saying, that in this case they want to divide this network into three sub networks, such that each network is having variable length addresses. So see here, this is 14.24.74.0/24. Now they want to divide this into three subnetworks such that each is having basically variable length of addresses. So one is having only 10 addresses, another one is having 60 addresses, another one is having 120 addresses. This is how they want to divide this. I have taken this example from the Frozen book, and this is the example where we have the variable length hosts in each of the network. In case of variable length division, I will always assign the subnet for the largest number of hosts first. Okay, so I will go in the decreasing order, which means I will decide the subnet for 120 hosts, I will then decide the subnets for 60 hosts, then I will decide the subnets for 10 hosts. Okay, so always see, this is very important, always go in decreasing order of number of addresses. So first you need to assign the subnet for the subnet which is having 120 addresses, then for the subnet which is having 60 addresses, then for the subnet which is having only 10 addresses. Now for 120 addresses, how many bits you need? You will be needing 7 bits, right? You will be needing 7 bits here. Now you have already 24 bits for the network ID, 24 bits for the network ID, and you will be needing 7 bits for the host ID, 7 bits for the host ID. Then how many bits you will be having for the subnet number? I think there's only one bit, right? So one bit you will be having for the subnet number, which means that you have a whole network which is 14.24.74.0/24, and then you will be having just one bit for this subnet, which means if this bit is 0, then this will represent this subnet. So you are dividing this into, currently you are dividing into two subnets. If this is 0, then this will represent this subnet. If this is 1, then this will represent another subnet, right? Now if this bit is 0, which means it will be 14.24.74.0, and then this 0 is fixed, then you can change this 7 bits. So you can change these 7 bits from all zeros to all ones, which means it will range from all zeros, which means 0, and all ones, which means 127. So it will be 14.24.74.0 to 14.24.74.127. Now in this subnetwork you have 128 addresses, and you only need 120 addresses. That is okay. So 8 addresses are getting wasted, but that is okay. Now let's talk about this subnetwork, which means the subnetwork which is having bit 1. So this was all about subnetwork which was having bit 0. Now let's talk about this subnetwork, and then let's go to this another requirement which is saying that you need 60 hosts or 60 addresses. So basically you have 14.24.74 dot, this one is fixed, right? This one is fixed. Now these 7 bits you can like, currently these are the host bits, and then you can change them based on the requirement. So it is saying you need 60 addresses, which means how many bits you will be needing? You will be needing 6 bits with in the host ID, right? In the host ID, if you are having only 6 bits, then you can have 64 addresses, which means you just need 6 bits here to have 64 addresses. So this is 14.24.74.1, and then you need 6 bits only, 6 bits. So this bit is free, which means you can you're like, if this is 0, you will be having one subnet. If this is 1, you will be having another subnet. So see here, you had divided this into two subnets, 0 and 1, and then you are saying for the one only you are dividing into further two subnets, which is 10 and 11. So 10 is this, and there will be another subnetwork which is having 11, and then these are the 6 bits, right? I hope you got the idea. So this is 10, where you are saying that it is having 6 bits. This is 11, here also you are having 6 bits. So this 10 will be dedicated to the 60 address block. So this has been dedicated to 120 address subnet. This you can dedicate it to 60 address subnet, right? because ultimately it is having 64 addresses, like 2 power 6 addresses, but that is okay. You only need 60 addresses, that is okay. Here you have 128 addresses, but you only need 128 addresses, but you only need 120 addresses, that is okay, right? Now the last requirement is having 10 addresses only. If you want only 10 addresses, then how many bits you need? You need 4 bits, right? So this 1 1 is fixed, which means you have this 1 1 as fixed number. This 1 1 is fixed, and you need only 4 bits. You need 4 bits here in the host ID. So how many bits are remaining? These are the 2 bits which are remaining. These are the 2 bits. Now basically, which means you are dividing this further, and these 2 bits you can take anything. I mean 0001 for this 10 subnet. So let me take just 00. So you can say that 14.24.1100. This is fixed. Okay, this is fixed, and then you can change these 4 bits. This is dedicated to a last block, which means let me just divide that into 1 1 is fixed, 1 1 0 0. So this 1 1 0 0 will be dedicated to last subnet, which is having only 10 data sets. Now what about these remaining addresses? What about these remaining subnets? These are not used yet. If in future, if there is some requirement that you can fulfill using this area, if you can fulfill using this area, then you can do it. Otherwise, that's not a problem. So we have fulfilled our requirement, which means we now know a block which is having a address of 120. We now know a block which is having an address of 60. We now have a block which is having address of 10 hosts or 10 addresses. Like basically total addresses are 16 addresses, but that is okay. So for subnet 1, this is the subnet 1, this is subnet 2, this is subnet 3, right? Now if you ask me, like, what are the total number of addresses possible in this whole network, then what are the total number of addresses? You will just say 24 bits are being used for the network ID, 8 bits are available for you, so total number of addresses are 256. 256 addresses are possible. I have assigned only 120 plus 60, which is 180, plus 10, which is 90. So I have assigned only 90 out 190 out of this 256. So 256 were available to me. I have used only 190. And some of the addresses I have wasted here. I mean 8 addresses, maybe 4 addresses I have wasted here, maybe 6 addresses I have wasted here, and quite a lot of addresses I have wasted here. So many of the addresses we have wasted, but that is okay. We are fulfilling our requirement. Right? Let's solve one more question to get more clarity. Suppose that this address is given to you and they want to divide this into 7 networks such that one network is having 500 hosts or 500 addresses. This is 200, this is like that, right? Now for 500, how many bits you will be needing? You will be needing 9 bits in the host ID. 9 bits in host ID. So first of all, tell me how many addresses total available for you. In total, you have 16 bits are available for the host ID. So 2 power 16 addresses are available for you, which is a lot number, which is like quite a lot number. And these are these requirements I think you can obviously fulfill. Let's just check. So 9 bits are required for the host ID here, and I will go in the decreasing order of the host size. So basically it is having it needs 500 addresses. I will go in the decreasing order. So which means I will first go for this 500, then 200, then 100, then 60, then 20, then 2, and then 2. Okay. So I need 9 bits here. See here 172.16, this is fixed, and I just need 9 bits at the last in the host ID. So how many bits are remaining? These are the 16 bits, and 16 and 9 is 25. 25 bits are being used, so this is 9 bits for the host ID. So there will be 7 bits, right? 7 bits I have for my subnet number. I hope you got the idea. So these are the 9 bits which are used for the host ID for this network, and 7 bits are available for the subnet number. So initially I am having all these 7 bits at zeros, right? Zeros. And then like these are the fixed, this is fixed, and then you will be having, you will be ranging these 9 bits, you will be ranging these 9 bits, and you will say that this is your first subnet. So what will the range of first subnet? In the first subnet you will be having, if you have 0 here, like this will be dot and then all zeros. So range of the first subnet will be 172.16.0.0 to to 172.16 dot, it will be 1 here, right? So this is the last bit of the this octet. So for this octet, this is the last bit, so it will be 1 if you have all ones in the 9 bits. So if you have all ones, it will be .1.255. This is the range of first subnet. This is first subnet range. I hope you got the idea. See, you are choosing the 7 bits as a subnet number in the first hierarchy itself, which means that initially you had this network which is 172.16.0.0/16, right? And then you have chosen 7 bits for the subnet number, which means you have divided this into 2 power 7 subnetworks, right? 2 power 7 subnetworks, which means 128 subnetworks. So one of the subnetwork is having all zeros in this 7 bit, and then this subnetwork will be having 0, 0, 0, 0, 0, 0, 0, 1, right? Last bit will be 1. Similarly, there are 2 power 7 subnetworks that are from all zeros to all ones in this 7 bits. Now for the first subnetwork, you are having this 7 bits, and for the first subnetwork, it is requiring a 500 hosts, right? So each of these 2 power 7 networks are having, in fact, 2 power 9, which is 512 addresses, right? Each of this is having 512 addresses, and first one requires 500. So you can allocate this block easily, right? So you are not over allocating, which means, yeah, I agree that 12 addresses are extra, but only 12, not not more than 12, because if you go for 10 bits, then it will be 1024, and if you go for 8 bits, then it will be 256. So 9 bits are accurate, which means you have, for the 9 bits, you have 512 addresses, and you require 500 addresses. Then you can allocate this particular, like, this whole block to subnet 1. That is okay. Now what about these networks? Now just see here, if you add up these all, this is 300, 360, 380 and 384. These are only requiring 384 addresses, and in this block itself you have 512 addresses, right? In this block itself. So you will never be needing these blocks. Like, there will be 2 power 7 minus 2 blocks, are like, whole these blocks will never be used in this division, right? So you will be only needing this block and maybe some part of this block. You will never need to use these other blocks, which means 2 power 7 minus 2 blocks will never be used. So I will do what? I will take this block, which means I will take the next block, which is 172.16 dot all zeros. I mean, 6 zeros, 1, 2, 3, 4, 5, 6 zeros, then 1. Right? These are the 7 bits. These are the 7 bits, and then I will change all of these bits. So these are the host ID. Remaining is the host ID. So this is the block 2. This is basically block 2. Now what I need? I just need this block 2 to divide into different parts, such that one part is having 200 addresses, another part is having 100 addresses, and another part is having 60 addresses, like that, right? So this block itself, this whole block itself is having 512 addresses, and I want to divide this into some parts, such that one block is having 200, 100, 60, 20, 2 and 2. Like that I want to divide. I hope you got the idea. Now let me go to the next page and let me show you how I can divide this network into further subnetworks. So which is 172.16.12345 zeros, then 1, and then these are the host IDs, right? These are the host IDs. Now I want to divide this network into some of the subnetworks. Now see here, I need 200 addresses, which means I require 8 bits in host ID. 8 bits in host ID part. This means that there are, like, these are the whole host IDs. I just need 8 bits. So I can further divide this into 2 parts. One is having 0, one is having 1, which means I can further divide this into 2 parts. One is 172.16.1234567 5 6 seventh bit, it is 1, and then 0, and then dot, there will be the host ID. So basically what I'm doing, instead of this bit, I'm writing this 0 at one place. This will be one division. At one place I will be writing this as 1, which means 172.16.0000001, and then 1, right? Then 1, then dot, it will be the host ID. So what I did, I have divided this into further two parts, and one part is like this was having 512 addresses. Now this will be having, if I have divided into two parts, this will be having 256 addresses, this will be also having 256 addresses. Now each of this is having 256 addresses, 256 addresses, right? Now what I need for this subnet 2, I just need 200 addresses. And since I cannot give only 200 addresses, so I will give 250 addresses and 256 addresses, right? So this block is completely consumed for the network 2. For the network 1, this block was consumed. For the network 2, I think half of this block is consumed. So let me just summarize it. For the network 1, you are having the network ID is this, which is 172.16. all zeros, right? All zeros. And then there are 7 bits that are fixed. So the mask length, this is also called mask length or prefix length, it will be 16 plus 7. So this is fixed, right? This is fixed. So which means it is 23. Now it is 172.16.0.16.0.0 to 23. This is your first network or first subnetwork, right? This is your first subnetwork. What about next subnetwork? This is network 2, where what you did, you took this network and divided into two parts. So basically this 10 is fixed, which means you are having 24 bits as fixed address as the network ID. So it is basically 172.16.2.0, 172.16.2.0 and 24, which means this everything is fixed till now, which means 24 bits are fixed, initial 24 bits are fixed, which is 10, which is 2. And now you can have like you can have 0 here or anything, because like this is just a variable. So this is your second subnetwork. Now for the third network, you need 100 hosts or 100 addresses, which means you need how many bits? You need 7 bits, right? For the third subnetwork, you need 7 bits. And just check here that you have divided this into two parts. Now this itself is having 256 addresses, right? This itself is having 256 addresses. Out of them, can you give 128 addresses? Because you can't give 100 addresses, then you need to give 128 addresses. Then how you will be giving? You will just divide this into also two parts, which will be 172.16.0, like all zeros and then 11, which is 3. This is 3 dot, now let me write in binary, this will be 0 is fixed, and then 172.16.3. this one is fixed, and then everything else is host ID. So this will be 128 addresses, this will be again 128 addresses. Now you need 100 addresses only, but you can't give 100 addresses, so you will give this whole 128 addresses. So what will be the third network ID? It will be 172. So if you ask me what will be the third network, it will be 172.16.3. This 0 is also fixed, right? This 0 is also fixed. So 0, like everything, like you can have anything here, but this 0 is fixed. But this subnet mask is important. So what will the length of subnet mask? This is 8 plus 8 plus 8 plus 1, which is 25. Select 25. This is your network 3. Now for the fourth network, what you need? For the fourth network, you need 60 addresses, which means you need how many bits? You need 6 bits, right? For the fourth network, you need 6 bits. Now see here like this is consumed, this is like you needed 200 addresses, that's why this is consumed. You needed 100 addresses, that's why this whole thing is consumed. You can't give just 100 addresses, you need to give 128 addresses. Now you need 64 addresses, right? Or 60 addresses. So you will be giving from here. This is having 128 addresses. Now let me divide this into also two parts, which is basically 172.16.3.1 and then 0. This 0 is fixed, and then this will be variable 172.16.3.11, right? This is 64 addresses. Now out of the 64, you need 60 addresses, that is okay, but you can't give 60 addresses. That's why I'm giving 64 addresses. For the network 4, so for the network 4, you will be having this as a network ID, which is basically 8 plus 8 plus 8 and then plus 2, which is 26. So you will say this is for the network 4, you will say 172.16.3.3. this will be 128, right? 128 slash 26. This 26 is important. Why? Because this is 26 length, which is fixed. 26 bits are fixed. That's why this 26 is important. Now this network 4 is over, which means you have given the 64 addresses in the network 4. You needed 60 addresses. That is okay. Now let's say what's going to happen for the network 5. For the network 5, you need 20 hosts or 20 addresses, and which means like you need how many bits? You need 5 bits or 4 bits. 5 bits, right? You need 5 bits. So you need 20 addresses. Now here, just see here you have 64 addresses which is consumed. Here again you have 64 addresses. So let me divide these 64 into two parts, which is basically 32 and 32. So 172, let me write it in the next page, 172.16.3.11, and then there will be this is variable. So let me divide this. These are the how many hosts or how many addresses are there. These are the 64 addresses. Let me divide this into two parts, which is this 1 and then this 0 is fixed, this will be variable, then this 1 is fixed and this will be variable. So these are the 32 addresses. Out of them I need just 20 addresses. That is okay. So what will be the length of the mask, or what will the prefix length? It will be 24 plus 3, which is 27. So you will be having 128 plus 64, which is 192. 192, these will be variable, so you can have anything. I'm just having it 0. Okay. So your network will be 172.16.3.192/27. This 27 is important. Why? Because these 3 bits are fixed. So 24 plus 3 bits are fixed. That's why this 27 is important. So this will be your 5th network. And for 6th network, what you need? You need two host only, or 2 addresses only. So what I need to do? I can just do one thing. Here we have 32 addresses, right? 32 addresses. So let me do one thing. Let me check first that how many bits you need. Here you need 2 hosts. These are the number of hosts. So you need 2 hosts, which means 2 bits. You need 2 bits. If you give 2 bits, then there will be 2 power 2 addresses, which means 4 addresses. Out of those 4 addresses, the first address will be network ID. Second, last address will be the direct broadcast address. Remaining 2 addresses will be your host addresses. So you need 2 hosts. That means you need 2 bits here. In the host ID, you need 2 bits, which means here just check. Here, like how many bits are available for the host ID? You have 5 bits that are available. 5 bits are available. So out of those 5 bits, you just need 2 bits as a host ID, which means let me just leave out only two last bits, which means 172.16.3.111, and these are the 3 bits. I just need 2 bits, so let me put them 000. Right? This will be one of the network. This will be one of the network which are having 4 addresses. This will be one of the network which are having 4 addresses. Similarly, there will be like you have chosen these 3 bits as a division. So basically there will be 8 such networks. Like you will be having 172.16.3.111 and then 001, and then these are the 2 bits which are available for the host ID. You will be having such that you will be having, like if you divide this into equal parts, you will be having 8 such subnets, but you just need one of them, which is this for your network 6, right? For your network 6. So this will be our network 6. And if you want network 7, network 7 is also of the same length of 2 hosts, then you can say that this will be your network 7. This will be network 7. There will be other networks, which means there will be networks like 172.16.3.111 and then 010 like that, right? And then there will be host IDs. So there will be other networks, that is okay, but we just need 2 networks. So for network 6, what is the length of prefix? It is 24 plus 6, which is 20, which is 30 basically. 24 plus 6, which is 30. So you will be having for the network 6, it is 172.16.3.224. Now your prefix length is 30. Similarly, for network 7, you will be having 172.16.3. This is 228. So you will be having 228 and then slash 30. This will be your 7th network. That's how I am dividing my entire network into some of the networks. So see here, my entire network was this. I have first divided that into 2 power 7 networks. Out of those, first network is like first subnetwork is completely consumed, which is for network 1, and from this block I have divided this block further into 6 other parts from net 2 to net 7. So I have divided this into 6 other parts, and these other 2 power 7 minus 2 blocks are still unused. I hope you got the idea. So this is about the subnetting.